inside, take a seat, get your notebooks out. So today we're going to be talking about the mole. In the past, we've been talking about atoms, molecules, what they're made of, and today we're actually going to talk about how we can count those atoms and molecules. So, because we have been talking about atoms in the past few days, I wanted to ask you guys again, what is an atom? Yes.
It's a thing that stuff is made up of.
Yeah, so it is what matter is made up of. What else do we know about it?
They're really small.
Yeah, so atoms are the smallest unit of matter. So beyond the atom, you can't separate it any further without it losing the integrity of being an atom. So what is it once we separate it? Does anybody know what three things it turns into? Yes.
Proton, neutron, and electron.
Yeah, so the atom is made of protons, neutrons, and electrons. And remember, the protons are positive, and the neutrons are neutral, and the electrons are negative, right? So we have our positively charged nucleus with the positively charged protons and neutral neutrons. And then we have the negatively charged electron cloud filled with the electrons surrounding the nucleus. So what else? We have the molecule, right? So what is a molecule? Yes.
It's two atoms stuck together.
So it's not necessarily just two atoms, right? It could be two or more atoms. A molecule is two or more atoms bonded together. And they can be from the same element, so they could be like two hydrogen atoms bonded together, or they could be different elements, so it could be like a carbon and a oxygen to like make carbon monoxide, or anything of the other combinations. It doesn't really matter as long as there's two or more, same element, different element, up to you. So, in science and in chemistry, a particle is different than what we call a particle when we're talking with our friends or our parents or somebody else outside of the science classroom or laboratory. So, in general, when we talk about particles, we mean really, really tiny things. So, like a sand or sprinkles or anything else really, really tiny. But when we're talking about particles in chemistry class, we mean atoms and molecules. So when I say particles, I'm not talking about sand, I'm not talking about sugar or anything like that. I'm talking about atoms and molecules. So today we're going to be learning, how do we count particles? So how do we count those atoms and molecules? So to start off, I wanted to see if anybody could guess how many particles, remember particles, are in the speaker. Yes.
1,000.
But there's probably a little more than 1,000. Remember, we're talking about particles. We're not talking about the actual granules. We're talking about the individual atoms in these, right? What else do we think? Yes.
1 million.
1 million? Any other guesses?
100 million.
Those are some pretty big numbers, but guess what? None of those numbers were big enough. Because there's actually 6.02 times 10 to the 23rd particles in that beaker. So that's 602 with 21 zeros after it. So remember, sometimes we don't really want to write out these really big numbers, especially a number with 21 zeros. So we can use scientific notation. So when we have it in scientific notation, all you have to do is move that decimal place to the right 23 times, and you'll have those 21 zeros back. But obviously, we don't want to write it that way a lot of times. So 6.02 times 10 to the 23rd is sufficient for talking about. So what is this number? So this number is actually called Avogadro's number. And so Avogadro's number is equal to 1 mole. And we're going to talk about the mole in a little more detail in a minute, but at first I want to just focus on Avogadro and his number. So Avogadro was an Italian scientist who studied physics as well, actually. So he focused on the effect of temperature and pressure on different molecules and whether they would become a solid, a liquid, a gas when you do different things to him. But actually, he did not invent Avogadro's number. A different scientist did name Avogadro's number after Avogadro to honor him 4 years after he died. So Avogadro didn't even really know that there was a number made about him, which I actually think is kind of funny. But Avogadro's number is this 6.02 times 10 to the 23rd. So whenever you hear Avogadro's number, your brain should immediately go 6.02 times 10 to the 23rd. So remember we said earlier that Avogadro's number, the 6.02 times 10 to the 23rd, is 1 mole. So what is a mole? So a mole is a unit that we can use to measure particles. So it's a standard scientific unit for measuring very large quantities of very small particles. So Avogadro's number is considered 1 mole. So basically what we're really trying to say here, if we're getting down to like the bare basics, is that 6.02 times 10 to the 23rd particles, remember this is Avogadro's number, is equal to 1 mole. So this is the Avogadro part, this is the mole part, and they're different, but they mean the same thing and they're representative of the same substance. So why do you think that we would need a mole? Yes.
To measure lots of small things.
Yeah, so we know that particles, what are particles again?
Atoms and molecules.
Yeah, atoms and molecules are really, really tiny. So sometimes it's kind of hard to talk about something that's so tiny that we can't really see it. So the mole helps us as scientists talk about substances without having to be so minuscule. Like I was saying, when you're doing an experiment, you're not necessarily going to be like, I'm talking about this particle right here. Because it's really hard as scientists to see that. We are going to work with a large amount of a substance at a time, so you can kind of see the reaction take place. So in this case, it's easy to be like, this is 1 mole of sugar. And every scientist will know this is 1 mole of sugar, and that will be a sufficient measurement for that. So yeah, the mole is really good for doing those sort of things, because I would much rather say that I have 2.3 moles of carbon than I have 1.38 times 10 to the 24 moles of carbon. Molecules of carbon, I apologize. But, it just makes it easier to talk about. So I like to think of it just like a dozen, so you can call it the same sort of thing. So if I went into a bakery and I asked for a dozen muffins, they're going to give me 12 muffins. Whether I ask for donuts, whether I ask for cupcakes, whether I ask for bread, a dozen is a dozen regardless of what we're measuring. The same thing is the case with the mole. So whether I'm measuring copper atoms or I'm measuring molecules of carbon dioxide, it is always 6.02 times 10 to the 23rd particles, regardless of what substance it is. So the mole and the dozen are very similar, and you can actually do very similar math equations with them. So I'm actually going to show you an example that is more of something from the bakery than the laboratory. So if I have 48 donuts, how many dozen do I have? So we're going to start with the 48 because that's all we're given, right? So that's where we have to start. So we will start with 48 donuts. And then we're going to be setting up an equation just like we did dimensional analysis in the past, very similar. So if we have donuts on the top, we know that we're going to have donuts on the bottom. And the reason we picked 12 is because 12 donuts equals 1 dozen. So remember, donuts on the top, donuts on the bottom, will be left with dozen. And this is so that the donuts will cancel and you'll be just dozen, right? So now that we have our equation set up, we can do our dividing. So 48 divided by 12 is going to be 4. So that 48 donuts is actually just 4 dozen donuts. And it's a lot easier for us to say I have 4 dozen donuts than it is for us to say I have 48 donuts. So now getting out of the Dunkin' Donuts mentality and into the science mentality, a science has 12 times 10 to the 24 molecules of carbon dioxide. How many moles of carbon dioxide does she have? So, again, we start again with what we have. So we have 12 times 10 to the 24 molecules. So we're going to write out here 12 times 10 to the 24 molecules. And then we're going to set up our equation. And so if we have molecules on the top, what's going on the bottom?
Molecules.
Molecules. So in this case, we have 6.02 times 10 to the 23rd molecules. And remember, that's the Avogadro's number. And Avogadro's number is equal to 1 mole. So mole goes on the top. So molecules and molecules, so it's in this diagonal, that cancels, so mole is left. So now we do the same thing that we did with the donuts, is we're going to divide 12 times 10 to the 24 divided by 6.02 times 10 to the 23rd, and we're left with 19.9 moles, because moles was what was left. So we're going to do one more problem, but this problem is actually going to be slightly different. If I have 15 moles of water, how many water molecules do I have? So last time we had molecules and we went to moles. This time we're going from moles and we're going to molecules. So we're going to start at the beginning again with our 15 moles. So, right, we have 15. And we're going to set up our equation. And so if we have moles on the top, what do we have on the bottom?
Moles.
Moles. And what number is going to go on there? It's going to be the 1. So remember, the 1 is always going to go with the moles because the mole is the bigger thing. It's 6.02 times 10 to the 23rd molecules per every mole. You're never going to want to put 6.02 times 10 to the 23rd moles because that's a lot of moles. We probably actually don't have enough space for that many moles. Remember, the molecules are going to be the part where you're going to have the Avogadro's number, not the mole. So again, we'll have that. And this time we just have to multiply across. Remember, we don't have to do any dividing because the mole is on the bottom. So 15 times 6.02 times 10 to the 23rd is 9.03 times 10 to the 24 molecules. So both of these problems are pretty much the same. It's just which one you're starting with. So it's make sure to pay attention when you're doing these problems. Okay, I have moles and I'm getting to molecules. Or I have molecules, or I have atoms, or I have particles, and I'm getting to moles. So you want to make sure that you're starting with the right number and that you're going to be canceling these units. So for the rest of today, we're going to work in groups on a worksheet where we're going to do more of these sort of problems. And I'm going to be walking around to make sure that anybody needs help. So if you need me, just raise your hand. If not, I will probably come around to check on you at some point. But yeah, we're going to just get started with the rest of our practice, and then we'll reconvene at the end of class to go over an exit slip. So, all right, get started.